Yeah. Hey, good morning, team. Welcome back. So we will be continuing the DLT journey today, and we will discuss a couple of examples with DLT, and then we'll talk about a assignment, and then we will probably will close the session a little bit early today. So I'm going to meet an event with Srini and other friends here. Um, So we will continue the DLT examples. Yesterday we have talked about. So have you guys watched the video, or anybody looked at the GitHub link that we shared yesterday? And the
Yeah,
code.
yes, you shared that demo video, right?
Yes.
Yes.
Yeah.
I
And
went through
GitHub.
that too. I went through that too, Hara. Yeah.
Oh, okay. Good. Good. The GitHub code as well, right?
Yes.
Okay. Nice. So basically, yeah. Let me share my screen and open the where we have done. Okay. So workspace. So I was talking about the issues, right, yesterday. So basically, same. So we hit the same error as you. The quota exceeded limit, right? That error. So we had to go back to the at the account level and then make sure you have enough machines allocated by Azure for you to process, right?
Yes.
Yeah, so that's what we did. So if you look at here, yeah, in the settings, if you go to your subscription, Azure subscription, and then if you go to the usage and quotas, there will be these machines that you have: standard, DS2, regional, vCPUs, whatever using. You can select these two and make sure you have enough machines here. So I put like 20, 32 machines here allocated, so that when you run the job DLT pipeline and then it requests for machines, so it goes and pulls the machines from here, like 12 machines or worker machines or 18 machines to process your. So currently only 4 and 4, 20%, 30% is what is the usage right now. Okay, so this is one of the troubleshooting that we had. I will show you the errors. There are no errors here. Previous. One second, let me. Yeah, these were earlier errors I fixed on the pipeline, but so that's okay. We will talk about the pipeline first and then see how when we are configuring, uh, what issues you might get and how you can handle that. Okay. Okay. So first thing, when you created the workspace, as I said, it is by default, you get new workspace, you get the Unity catalog enabled. Okay. So when I say Unity catalog, when you look at catalog here, you have a Hive meta store, and then you can also create your own catalogs, which will be assigned to your own meta store. Okay. So this is the workspace I'm using. This is the catalog. You see workspace catalog. And then I have created a demo schema in this. And then we have tables and volumes here. This part you're clear, right? You are already aware of catalog tables and everything.
Arun, I have a
Yeah.
small doubt.
Sure.
So when we are creating a cluster, it will ask for single node or no isolation shared, right? So when we select no isolation shared, Unity catalog will not be created, right? Like if we create single node, it will create Unity catalog.
No, it does not have anything to do with the
Yesterday
cluster.
I tried Harun. Yeah, if I select a no isolation shared, it's not creating Unity catalog.
There is nothing to create a Unity catalog, actually.
Okay.
So your workspace is by default UC enabled. Okay. So Unity catalog is at the workspace level, that is already enabled. When you talk about the cluster compute is below that. So you can create a compute and use for any jobs within that workspace or to access any of the catalog objects within that. Okay. So Unity catalog is not an object. Okay. It's just a concept. It's a data governance tool concept that where you can create your catalog schema and table within your workspace. Okay. Otherwise, if it is not there, you will only have this, and everything you create will go to this metastore database, and then scheme database and tables in this. In the Hive meta. If it is UC enabled, you can go and create a catalog and then have your database and schema. So this catalog, schema, and then you can have your tables or volumes or whatever in this. Okay.
Okay. Yeah.
All right. Okay. So once we have created this, so I have so I have shown you yesterday the GitHub, right? So one thing I've copied is the New York taxi fares. When you look at this, so this is a repository, just like yesterday we talked about the pipelines workshop, right? Remember? Yesterday in the video, this is what we have shown, pipelines workshop that was done in the event. So today, what we are doing is you invite taxi fares. I have shown you yesterday also, like how you clone this, right? So you go here, go to workspace, okay? And then you can go create Git folder, right? And then you have to give the URL, Git folder URL for Databricks up till this TMM. Okay. So this is the main URL, main tree. Okay, root. Sparse checkout mode. In the cone pattern, you have to give what is the folder here that you what is the folder that you want to clone. Okay, so yesterday we did pipelines workshop so now we can do NY taxi fares. So just copy this NY taxi fares like this, and then put it here in the cone patterns. Okay, and then do create Git folder. So once you click this, you will automatically get your folders here. Where is this? See here, NY taxi fares. Okay, so you will automatically get this repository. It is actually under users. Here in the home, TMM NY taxi fares. So you get this DLT pipeline and then README. And so this workflow, so you don't need to worry about this. Just you will get these two. Now go to README. So this is taxi fare data analysis pipeline. So it will talk about what it is doing, right? Streaming table, taxi raw records. What is the source? What is the silver layer? What is the gold layer? What are the key features of this pipeline? The streaming data processing, data quality checks using DLT expectations, streaming table for ingestion, materialized views, and medallion architecture that we already know. Okay. So this is the, so you need to have samples, NYC, taxi, trips, data set. Okay. So where is this samples, NYC, taxi, trips? If you go to the catalog, by default, you will have samples. Okay, check your workspace. By default, you get Hive Metastore and you get samples. So if you go in the samples, you have a NYC taxi schema, and then you have table called trips. Then you can view the sample data if you have data in this. Okay, so what does it show? It's a pickup date time, drop off date time. What is the trip distance? What is the fare amount? And then zip code, pickup and drop off zip codes. So this is the data that you have. It's a huge data set. So whatever data we have. So this is one DLT pipeline example. Okay, so we will run this. But before that, this is another example. I want to run this first. Then we will go to that thing, to the New York taxi. I have not executed. We will try that. Okay. So what I have done here in this pipeline, data pipeline here is, this is the baby names. Okay. So again, so this is the DLT. Yesterday we did, I've shown you the SQL, right? So this is a declarative. Now we are using Python. Okay, DLT declarative Python code to create the DLT pipeline. So import DLT, PySpark SQL functions, right? And then these are the, this is the configuration setup, let's say. Okay, so you don't have to worry too much about it, but understand what we are doing here. So what we are doing here is we are setting up the path for files to get the files. So what is the path? Volume, UC workspace, demo schema, UC volume. Okay. So where does this come from? So let's go here. Go to catalog. So see, observe here. What is this? Volumes. So I'm taking, go to volumes. Where is this volume? UC workspace. So this is the UC workspace catalog. Under that, you have demo schema. I created a demo schema. So this is a demo schema. Under the demo schema volumes, I have created a UC volume, right? So under the demo schema, UC volume. This is the storage location I'm using. Okay. Now, what is the file? The file is this. It's on the web internet. So I am pulling that file using the URL health data ny gov API views rows.csv. This is the file. This is the URL and this is the file name. Now, dbutils.filesystem.cp. CP is copy. Okay. So I am copying the file from this URL to this location. Volume path. This is the volume path. And this is the file name. With the same file name, I'm copying. So I'm actually pulling this file from the internet, and then writing to this storage location with this file name. Okay. Is that clear? Everybody? What we are doing here, we are just setting the data.
Yes, sir.
Yes.
Manas,
Yes, sir.
Is this how we get data from a URL, Harun, usually?
Yeah. So if it is a public URL, which is available, APIs, through APIs, if you hit the API, you can get. If you get, this is how you can use .get. So copy from this path to this path.
Means we can get any kind of format files. Like here is this
Just
file is based.
download, right? So you're just downloading it from the URL.
Okay.
So any file, it can be CSV, JSON, whatever file it is.
Hmm.
If that file is publicly available, you can just pull it. Okay. Download it. Download, and you are writing to this path here in this volume. You can go and check in the volume also how that file looks like. If you want to, we can check that. Now, once the file is there, okay, so we are saying in first schema also just true. Just take whatever is there in the CSV. DLT.table. This is declarative, right? Delta live table. Comment. Popular baby first names in New York. This data was ingested from New York State Department of Health. This is a comment. What is the baby name? Baby names raw. This will be the table name, right? So you're defining the @DLT table, and this is the definition. Spark.read.csv. Remember, so this is a CSV file. Path, file name, header is true, in first schema true, just like what we read CSV file. Then we are renaming first space name to first underscore name. Okay. We're just renaming one of the column names, and then we are returning this data frame. So that will become your raw table.
Harun, why do we still have to use all these complicated? Since we have already downloaded and created that, can't we use the file path directly? .csv.file path.
Yes, you can. What is complicated? So why we have why we are using this, right?
Yes. Usually we just write the file path, right? And since we already have the file in our location.
Yeah, I understand. Suppose let's say I have given you this file, okay, and I have put that path here. Now you run it. So do you get that path? On
No.
your environment, you might have different names, right? Your
Yes.
volume might be different. Your demo schema might be different. Whatever file names might be different, right? So in industry, you have, see here, you declare at only one place. You don't write the same thing again and again in 10 places. Now, when I give you this notebook and you create, let's say Shanmuga, right? SH or SM workspace, SM schema, SM volume, something. All you have to do is just change here. Just this one line. You don't have to change anything else. So everything else will run because it is using the environment variables. Now, if you remove all of this, you have to change here, you have to change here, you have to change here, and wherever you are using, you have to change everywhere. Right? So the
Yeah.
best practices, you declare at one and use those variables in your program. Because once you change here, everything will reflect because you're using the variables. Now, one interesting use cases, right? So even you will not hard code like this also in your actual work. Right. So there will be some JSON configuration file, as I was stressing, talking about it multiple times. For any data source, they will already have a configuration file, most likely JSON file, right? First, you read that file. That's the only thing you will hard code. The config file. Where is your config file? And from there, you get all these variables. So if you have to change, you will just go and change the data in that config file. And that file will be in your standard, say they will give you. So dbfs, this is the path. This is where the config file will be. And maybe you will have one file for each for each notebook.
Notebook or something. Yeah.
Right. So that will be centrally located and managed so that, everybody just don't go in and do the changes. Right.
Yep.
So one second. Okay. So yeah, so for each notebook, maybe there will be one JSON file, and then whoever want to make changes, again, we will go through that. So you will create that JSON file, and then you will push it into the repository. When you move your notebook or code, you will also send, this is the configuration file that is required for this job to run. And then you access that configuration file in your job, in your notebook. Okay. All right. So then we are creating baby names prepared. So what we are doing, we are taking just this raw table and cleaning up and preparing for analysis. What are we cleaning up? We are saying valid first name, which is first name is not null. Okay. If the first name is null, it will drop. And valid count. Count should be greater than 0. These are the two expectations. Should be expect or fail. If it is not greater than 0, it will fail, it will stop. Now DLT.read baby names, this one, baby names raw, with column renamed. Year we are renaming to year of birth. Okay. Select year of birth, first name, and count. These are the three tables that we are using. These three columns we are using.
Harun, I'm sorry to interrupt you. So basically, we are defining a function here and trying to call this function. I mean, we'll call this function and try to get the whatever the transformation that are there as an output of this function, if I got that right. Yeah.
Not so. It's actually returning a data frame.
Yeah, data frame. Yeah.
Yeah. So whatever functions, how DLT declaration works is, we were discussing yesterday also. Since you said DLT table, DLT expect are your constraints that you define on your table. Right? When you read the data, it will validate these conditions. Just like say where clause. Okay, where first name is not null and count greater than 0. But if count is greater than 0, it will not greater. If this condition fails, it will fail. It will fail the job. Okay.
Mhm.
Now this will be the table name since you said at declaration at DLT. So whatever is the function name, he will become your table name. And you can also give here as a specific table name also. Then it will use that table name. Otherwise, by default, it will use this as the table name. Okay.
Mhm.
And how do we create the table? Using a data frame. Let's say, so in the batch jobs you have written, right? So you have a data frame, you do df.write, and then you give the mode overwrite update, or then you give the path,
Correct.
the dot write mode, delta format, and all of that, right?
Mhm.
So basically, you're writing the data frame. That's when your table name is created, and then you give the table name there. So the same thing here, it will take this as table name. So whatever you're returning this data frame, it is reading from this, right? Dot read from this table. Then it will apply these transformation, like just rename the column, right? And then select only 3 columns from the data set, from the
Yes. Yeah.
and then it will return the data frame. So that data
Mm.
frame will be written to table with this table name.
Oh, great. Awesome. Thanks.
Yeah. Okay. So that is your silver. Now,
Mm.
gold. What are we trying to do in the gold is we are trying to aggregate and see, summarizing the counts of top 10 baby names in New York for 2021. So in 2021 in New York, what are the top 10 baby names? Okay. So what is the baby name? How do you write the SQL? You write, select first name, comma, count star, group by first name. Since we want to do year, first you filter, saying that, year of birth, take only 2021, and then do a count, total count, top 10 baby names for that year. So that's all you do. So you get first name, total count, limit 10. So you're only taking 10 baby names, the top 10, because you're doing a sort descent. Correct? So this is your pipeline. This is your notebook. You're clear?
Yep.
Yeah. You're first downloading the file, storing it in your volume. You created a volume, stored the file in the volume. Then you created a raw table. Then you did some expectations, validity, check valid conditions. Then you come here and do the aggregation. So that is what you do with this. Now, this is the notebook. Now you have to create a DLT pipeline for this. So you go here, delta live tables, and then you create this DLT pipeline. So how do you create? Let's go here. Okay. And then say create pipeline. Yesterday also we have gone through this, right? So you give pipeline names of baby names, or just a DLT. So we'll just leave this triggered. Just use core. 2 to 6. Okay. Whatever. Once. Path. Where is my path? Is this the one?
DLT shell to users.
Users.
Let's go here and check. Yeah, so it's just a DLT example, new. That's the notebook we have written. Storage options, use Unity catalog. Select Unity catalog, UC workspace. Schema, what schema you want to use. Demo schema. So you can just leave it. I just used only one worker in this so that I don't use too many machines. And then can come here, instance type, use standard, whatever is general purpose, DS3, V2, 14 GB, 4 cores, same as worker. So this is all you have to give. So you get 1.5 dB per units per hour. This is how you will be. This is how generally it is charged based on the dBs. As Databricks is units, how many it will consume per hour. So summary. Okay. So once you do this and then create, you will get your pipeline. You will get this pipeline. So you won't get this graph until you run this. Okay. Now, baby names raw, baby names prepared, top baby names here. So go to catalog. You see workspace, demo schema, tables. The three tables here. Okay, let me SQL editor. Yeah. So what I will do, I will just go ahead and drop these tables. I'm dropping these three tables. So it kicks up a serverless warehouse. It's just like a SQL warehouse that you connect to. And then
Can't
that's
we
done.
declare it so that it will drop if the table already exists while writing declaring the DLT tables?
You don't need to. You don't need to drop it all. It will automatically run. I'm just trying to show that first time when if it's not there, it creates. You don't need to drop it every time. It will automatically check that.
Okay.
Okay. You don't need to drop every time you run the data pipeline. This is only the first time. So when you write the pipeline, these tables are not there, right? So this DLT will go and create that. Correct? So now if you go here,
Yes.
see in the UC workspace demo schema, there are no tables. There's only one volume. That's it. One row CSV, but there are no tables, right? Now we'll go here and start this Delta pipeline, DLT. Might take some time for resources.
Arun, one small
Check
question.
the settings for this. Yeah.
What is the meaning of volume and what's the difference between table and a volume?
Volume is just like your folder storage. Just you drop your files there.
Okay.
Okay, that's on storage. It can be internal or it can be external. Internal means you are storing on your Databricks DBFS, like how we are storing here in the path. External means you can create a volume, an external location, which is your ADLS, Azure Data Lake, or S3,
Logs.
AWS S3. your files can be there as an external location. You create a volume, and in that you can add that external location pointing to that location, either in AWS or in S3.
Okay. Can't we do that with the tables?
No, see, tables also, as we said, right? Tables are two types, managed and external. If it is a managed table, wherever you have created catalog, right? So wherever your workspace, your catalog, by default, they will get stored there. Okay. But if it is an external table, when you are writing to that table, you specify the location, that external location. So data will be, if it is S3, okay, when you write to this table here, it will go and save in the S3 files. The data will not be there in your Databricks here, Azure Databricks or Azure. It will go and write to the S3, and it will read from there only, if it is external table. Okay. Now, if you drop the table, only your table will be dropped. That file or data will still be there in the S3. That is external. But if it is managed table, so which means that your table data, everything is here. Right now, whatever I have created was managed table. So if I drop the table, data is also gone. So that's how tables work. Volume is just like your, Windows or whatever the folders that you have, right? You create a folder and you put files in there, and you can read those files from there.
Okay.
Okay. So that is your volume. None those are tables. Where is the pipeline? Oh, we come here. Why am I jumping around this one? Still waiting for resources. Okay. While we are waiting for this, any questions?
Arun, is that because one worker we took, that is the reason it is taking time?
No, it's still trying to get those machines allocated.
Okay. So does it take this much time? I mean, I'm just on
Yeah,
because
first
since
time,
you're
right?
running.
First time, every time you run, there is, yes, it has to request machines, create compute and all of that. That is why we are saying, again, it's serverless. Okay. So serverless will be faster. We looked at,
Can
I
we
tested
connect
it
pools while
immediately.
making a pipeline, Arun?
Sorry?
Can we connect to pools while making pipelines?
You can, but it will only uh, request for machines when you actually execute the pipeline. But this is only the first time. Once you get resources, if you want to run subsequent, those machines are already available, warmed up. It will be faster. Okay. Normally, yes, that's why if you go to serverless, it just less than 10 seconds. Okay, see, now we got the resources. And then now initializing. This is when it reads your notebook, checks all the syntax and more almost like compiling stuff, verification and all of that. So once that is done, it will start setting up tables, that is creating and executing, and then run your graph, render the graph. Okay. So this is planning. Now this is running 3 seconds. See, first it runs the raw table. This is completed. Then it is prepared. This is running. And then this is queued. This is running. This completed. Now you can also see how many rows this is here processed.
9,40,000.
Yeah, no, 94,
94K.
94,000.
94,000, sorry.
Yeah, so this is also 94,000. Okay, there's nothing data that was dropped. And then here you have the aggregations. So you have 10 rows because you limit by 10. So it has 10 rows. Now you can go here, check data. So there are no tables here right now. Refresh. See, now you got 3 tables. You can go to aggregation. Okay, let's just go this. Comment out this. Run this. So these are the top 10. Got it? Now, as we said, you can, so since the pipeline we have set in the settings, it is triggered, it's not continuous. So it's going, once you run it, it will run and it will stop so that you don't get charged. If it is continuous, it will keep running and looking at the data, whatever is coming in, and then run the tables. So if you want, again, the whole pipeline, you can still schedule it you can still schedule it how you want to run or trigger it. But in triggered mode, only you will do it in development. In production, you will put it in the continuous mode because you want to do the live table streaming data that is coming in, right? Otherwise, you can just do your batch and schedule that batch as workflow. So overall, it's the same thing that you are achieving, right? But if you want to do something streaming data as and when it is coming in your processing, so you something like streaming job, you can use DLT pipeline and keep it running continuous. Now I go here. And then I can do another run. Okay. So it will start again. But this time, see, the resources are already there. It's not released resources back yet. So we can immediately use those resources.
Are we being charged in between those triggers for the
No,
resources?
when we are using those machines.
Okay.
So Harun will be learning around close to 1,000 plus something like based on the requirement, isn't it? This is just one pipeline. So similarly, we'll be running thousands of pipelines, right? I mean,
Yeah, it depends on what complexity of the enterprise. I wouldn't say thousands. Generally, unless it's a huge enterprise, there's something like Netflix or credit card transactions are huge, where there are transactions are huge. Yes, there might be, Twitter, X, whatever those you call that, right? Social media platforms or digital streaming media. Those are huge, and credit card online transactions or Amazon. So those are huge. You will have, you can say, more than thousands of things. But if you look at mid-sized standard enterprises, I don't think there will be thousands of DLT pipelines. Maybe tens to hundreds, less than 100 or something like that. Again,
awesome.
The entire thing will not be on DLT, right? There are different use cases. There will be some batch jobs. There will be some streaming jobs. There will be some DLT pipeline. It will be mix of all. It's not like one use case fits all. And not, you cannot put entire thing on the DLT. So again, if your data is coming in, say, from the source, right? So what will you process if you don't get source? Let's say from the source, you are only getting once in an hour data. or once in a day files. Why would I write a
Mhm.
DLT pipeline for that?
Mhm.
Or even if I write, why would I would not make it continuous, right? I would make it triggered and schedule it in just batch jobs. But if the data is streaming, like as I said, Twitter or X, right? So then I would need a continuously processing pipelines, streaming pipelines.
Mhm.
So there you will having a DLT makes sense. Streaming data with streaming makes sense.
So when we say it is more than 1,000, so it got to be obviously stream data.
More than 1,000 pipelines, you're saying?
Yeah.
No. So see, even if it is less than 10 pipelines, there might be streaming data.
Okay.
Or if it is
I'm
100,
sorry, just like because I was just going through your introduction classes, everything and all. So it's making more sense now. I mean,
yeah,
I just started the revision.
sure.
So just trying to
So
connect it.
that's what I said, right? Number is not a criteria. It's what is the use case? How important or critical it is to process the streaming data.
Mhm.
Okay. I always come back to the same credit card example, right? So fraud detection is the most relevant use case. When the same credit card, let's say, is being used from two different places,
Mhm.
I cannot wait to process it until next day as a batch,
True.
right? And I am using my credit card somewhere, and it does not allow me because it senses there is something happening. Sometimes you get a message saying that, are you trying to use this card here? Transaction is blocked. You respond to this. So you check and you say respond, yes, I'm using it. Then again, the transaction goes through. So how is that happening? Because it is a streaming data. As the moment you put your card, the transaction goes in, and that streaming, it's immediately processed. It's joined with all other your current data. Okay, let's say you are in one zip code, right? And you have processed your card, used your card, and then in next 5 minutes you're using the same card, and then now you are using from a different zip code, which is say 100 miles or 200 miles, something like that. So it obviously detects, the zip codes are much far away or different zip codes, and the time is less than 5 minutes. Is it a true transaction or is it a fraud? So all that machine learning algorithm, it has to combine with existing data. It has to look at pattern, right? You have been using your card in the same zip code for past 3 months, and suddenly your card is used in some other country, right?
Okay.
So those things
Yeah.
you have to continuously, immediately process it, look at the pattern, existing data. It has been trained on your data, your card. What is your pattern? Are you continuously moving in different zip codes, or you're only using in one zip code, right? So it has to make a decision that is it a good transaction or a bad transaction. That is a streaming. That is urgency, critical. You cannot have batch, or you cannot run in trigger mode in 15 minutes or 1 hour or whatever. So that is, as soon as the data comes in, you have to process. So that will have too many pipelines. Again, the same pipeline may be cloned. It may be running, the same pipeline might be running for different geographies, for different areas to process on multiple machines, right? On different topics, data that is coming in from different zones. So all that you have to think about the use case, and then look at the data that is coming in. Based on that, you create the pipelines.
Awesome.
Okay.
So if you're trying to apply for a jobs in a banking sector, so we should be good with the streaming part, isn't it? I mean,
Not
with
just bank,
everything
right?
also.
As I said, it can
Yeah.
be a social media. It can be
Okay.
retail.
Mhm.
So if you are Amazon or Flipkart, That's also like huge transactions that are coming in. IRCTC, huge transactions, right? So it's based on how many transactions you are processing, what are important, right? It's not about only banking. We cannot specify. In every domain, there will be critical use cases. Okay. In every domain, there will be none. See, even if you say bank, let's say the bank only specializes in loans. Okay? And the loan processing. How many loans do you process in a second or in a minute? Not much, right? Or if your bank is local, it does not have many branches or many customers. So it's all depends on how many transactions that are coming in, volume, and criticality of that, how important it is to process immediately. So these are the different factors that come in. It's not just one factor that is considered.
Great. Thanks, Arun. Yeah.
All right. Okay. So this is this pipeline. You're good with this? What we're doing?
Arun, why is it saying materialized view?
Yeah, it is a table. Sometimes it represents as a materialized view because whenever you run, it will automatically refresh that data in the view or in the table kind of. So that's why it represents as material. Even I got that data. Why? Because I have not declared it as a materialized view when I wrote the DLT, right? So I just gave it as table. In the graphical sense, it represents like that. Okay. Now, so question, what is this? So if it is just for this year, right? I have done. What if I want to get top 3 for each year? What are the top 3 baby names or top 10 baby names for each year? Why do I want to look at only 1 year? How do I do that?
Something in the aggregation, I think with a group by.
Yeah.
What's your
First, we
question,
don't have to
Sahil?
filter with the year.
So if I see currently it is showing top 10 baby names for the year 2021. Of course, we have not shown the year there. But yeah, if we want to do by year also, each year, if I want to get top 10, that's when you go and remove this, right? Expression, you remove it. And then in the group by, you also need to add the year.
Here.
Okay? And then limit, probably you have to do based on all of the years, not just the over the top just 10. Each year you have to get 10.
You fulfill that one. Means if you use the rank function to do that, rank means you want to rank by year and
rank by year and then descending count.
descending by total count.
And then rank less than 10, something like that. You will create that window functions, aggregate and window functions. Okay, so that's how you do this. Okay, are we good with this example, everybody?
Yes,
Yeah.
sir.
Okay, so I will share this notebook. So there are no files. Source data is already in here. But make sure when you create this workspace, schema, and volume, you replace that dot here. Only this line has to change. That's it. To run. Okay. All right. Now let's see another example. Okay. I haven't tried that. We are going to do it here. If we hit any issues, we will look at it. Okay, and then work on that. All right. So I was taking this NYC taxi fare data. As I said, there is trips that is already there in samples, right? And then I have cloned that. I've shown you, right, how to clone it, that data. just a SQL editor. Let's go back here. Workspace. Okay. So this data set is also available here if you want to. But again, once you create in samples, you will also get that data. Create or refresh. So this is SQL based. The other one we just saw is the Python based DLT, declarative. Now this is the SQL based. This is the same as we did in the lab the other day. Create or refresh streaming table, taxi raw records as select star from stream samples.nyc taxi.trips. So this is the when you create, you get here. By default, you get samples. Go to catalog. You can see here. Samples, NYC, trips. Okay. So we are reading from that table from stream, select star. Constraint, valid distance, expect trip distance should be greater than 0. On violation, drop the row. Okay. So which means your trip distance should be greater than 0. If the trip distance is 0 or negative or whatever, all those rows we are dropping. This is the first taxi raw records that we get. Where does it create? That is another good question. Okay, we'll give it that. Then create or refresh streaming table, flagged writes. This is a silver layer. It's a data transformation and cleansing. We look into short trips or trips within the same zip code that cost more than $50. How are we doing this? So this is all SQL based. This is nothing with the Databricks. It's just pure SQL. Select date, trunk, week from this. What is the week? Pick up zip code, fare amount, and trip distance from raw records, right? So this is the taxi raw records, raw data, where pickup zip equal to drop off zip, which means, as I said, the pickup zip code and drop off zip code is same, which means that you are just moving in around in the same zip code. And fare amount is greater than $50. Okay. Or trip distance is less than 5. So you're going less than 5 miles. You're traveling less than 5 miles. And fare amount is greater than $50. So you're trying to see which rides cost you more for less distance. This is one. Flagged rides. This is weekly statistics. Create a refresh materialized view weekly statistics as select again week, average of fare amount, average of trip distance from taxi raw records, group by week. So every week you are taking and averaging the amount, fare amount per week and trip distance per week. This doesn't give you much information. This is just how to do a weekly aggregate on this. Now on the gold layer for downstream, what are we creating? Top N. Weekly statistics with flagged rides. So we have created two tables, right? Flagged rides and weekly statistics. We are taking both those tables, select week, round average amount, average distance, fare amount, trip distance. We are joining those two. Flagged rides, left join weekly stats. Flagged rides and weekly stats. These are the two tables that we are joining on week for each week. Order by fare amount, limit 3, top 3. So you're taking left join because even if there is no data on the right, you would still get the weekly stats on the left table. The rights. Are you good with this? What we are trying to do?
Yes, sir.
Okay. So we have seen the trips this data, right? New York taxi trips data here. Right? So pick up, drop off. So from this, he's trying to take the week of this date. This is the distance, this is the amount, and these are the zip codes. Okay. Now, so this is the NY taxi DLT. Let's go and try create the DLT pipeline for this. Create pipeline. Let's say NY DLT. Let's NY taxi DLT. I'll just leave it triggered. Path, source code, go here, TMM, NY taxi fares, NY taxi DLT. Right? So this is my notebook that I'm using. Storage options, Unity catalog, select a catalog, UC workspace, target schema, demo schema. I'm using the same schema, right? Workers, let me use just one worker again. I don't want to spend too much money on this right now. And not super critical, right? Is processing old data. Okay. Worker type, again, I will choose general purpose this. Driver type, I'll just leave it same as worker. Good. Okay. So there is one more, there's one more feature, right? If you observe, I'm not able to see here. We'll have to check where that thing is. Serverless. When we talk about serverless, we get an option here when we create a pipeline to use serverless. So yesterday we were seeing, right? When we ran the lab experiment, there was serverless here. So when you enable serverless, then you don't get these configuration machine and everything. Okay. So let's go create this. Okay. Have to start. Let's see how long it takes for resources. Again, this is a new pipeline. It's requesting for resources.
And Arun, so how we can decide that a notebook is SQL or PySpark?
There is so there is no one. There's no hard and fast rule. That's what I was saying. Even when we started, right, right from the session one, I was saying there is no hard and fast rule. It's preference. You can do either this or that.
Okay, whichever is comfortable for us,
see,
we can take it that one,
yeah,
right?
In organization, the architects will share it, decide and share a template. Right? They will discuss and share some rules and say, okay, we are using Python for, let's use Python for the notebooks, or let's use SQL for the notebooks. Okay. But I don't think anybody will restrict you. It's all open source. There's nothing like, no, it was like olden days. You have to write in Java only, you have to write in this only. Right now, mostly all Databricks notebooks are popular both in SQL and Python. Python mostly because it is used in ML notebooks. When you want to do ML experiments, ML notebooks, feature serving, creating models. So all of that is, you have no option. You cannot write that in SQL. It's all Python only. But in data engineering, you have an option. You can use both Python or SQL, right? So it's personal preference. No, but I don't think anybody will restrict you saying that no, you cannot write SQL. But there are always exceptions. Sometimes for some reason, your architects might decide it's not, we cannot maintain if we have both, or they want to do just one. So very few times they might say, no, use only SQL or use only PySpark. But in general, I haven't seen anywhere saying that you cannot use this or you cannot use this. Most of the time, it's the choice of the data engineer. And the normal notebooks, anyway, you can mix and match, right? Batch.
Yes, yeah, yeah.
But in DLT, you cannot mix and match within the same notebook.
Okay. So DLT, that is the restriction then, right?
Yeah, limitation. Either you can use PySpark or you can use SQL within the same notebook. You can have multiple notebooks, but within the notebook,
in the notebook, only one language you should be.
Yes, yes. All right. Hopefully they should work. But yeah, while this is running, one second. Let me check something. I had to check my email for something.
Harun, in real time, how companies frequently use DLT, or this is for military purpose, what we are learning here?
No. Real time also people do use DLT.
Okay.
There are a lot of implementations of DLT. Databricks is pushing DLT, right?
Okay.
So you have a lot of benefits. One is you see the lineage. The moment you run that, you can see how the data is moving from which tables to which tables, or how that view is being generated. You get a graphical representation, right?
Yes.
Yeah. And also it is continuous. It has benefits. You can automatically take up the data ingestion if you just have to use live. That's it. And it implements the CDC. So whatever new files that are coming in, it will automatically read those. So you don't have to write all that read streaming, checkpointing, all of that is taken over. Serverless is supported. You don't have to do about creating compute like job compute, all purpose compute, and how you want to manage all of that stuff. So a lot of complexity is taken off, right? So and you're getting a lot more benefits. So that is why DLT is definitely being used. But again, as I said, it's how one of the organizations I worked for, they did DLT. They did a lot of DLT, but then they kind of rolled back, right? So they put some use cases in DLT, some they take out, and then they used DBT. There is another transformation tool to do transformations, and they created batch jobs with DBT and then scheduled, because again, in production, right, it is continuously running, so you get cost when it is continuously running. And then, as I said, they had some use cases where it was not urgent or not required to run continuously. So they moved and then looking at the cost. So it has to be a trade-off. If the cost is high and if it is not important, then why do I want to spend money? So that's when they make a trade-off decision that some DLT pipelines, they moved out, converted to batch with DBT as the transformations. Some they put it in DLT. So it's kind of trial and error and the trade-off between the cost and the value, how important it is, right? So DLT is definitely there. People are using DLT. So it's not like it is not.
Okay. Yeah. Thank you.
You can, in the interviews, you can create some use case and tell them, yes, we have done DLT and we have configured DLT. Okay. So earlier, we also used to prepare the use cases and then talk about what is the cluster size, what size we have used, how much volume we have processed, how much RAM was each, how many executors were there, how many workers were there, how many cores were there. So all of that calculations also we used to prepare, but now, as I said, things are moving. The low level abstraction is being taken out. It's, it's all being handled. You have to, it's the job of engineer is on, what are the use cases, how I can use these features. That's what it is.
Okay.
Not trying to go deep into, everybody don't have to do the same thing, invent the same, wheel again. So now with serverless, you don't have to talk about infrastructure, right? Now with DLT, you don't have to talk about checkpointing, ingestion and all that. So you just say we use DLT, we use autoloader, which comes in, it reads from the cloud files. You can say ADLS, we get source from vendors onto ADLS, they write to ADLS and we run a DLT pipeline. It reads from ADLS the files and processes automatically and then puts it in the aggregations. We don't have to do anything. It's all automated. Source comes in, BI can read the data. It is continuously being updated. You can say development, we do using, we schedule the triggered mode in development, we run, and then when we migrate to production, we leave it on continuous, something like that. And within that also, yesterday we have seen, right? So you have an option when to refresh. Even in the DLT pipeline, you have an option to see refresh timeline, 6 hours or whatever. Yesterday we have seen for one of the tables, right? Okay, let's see, where is this? Awesome. Where is this? Okay, beautiful. We got this. Okay, taxi, raw records, 22,000 processed, flagged rides, 19 records written, weekly statistics, 10 records written, top N, 3 records written. Cool?
Yes.
Awesome. Now, let's go here. Let's just catalog. Use catalog. Refresh. Where are the tables? Where did it create?
Unity catalog use under UC, right?
UC workspace?
Default schema?
Not default.
Demo schema.
schema.
Demo schema.
Tables. These are the baby names one. These are the flagged rights. Taxi raw records, flagged rights, and top N. Okay. So if you look at top N sample data, it's only 3 records we have taken. So this is the one. See, average trip distance is 5 miles. The fare amount is $95. Okay, for 5 miles. This is the average anyways. Average of 0.92, $60. For 2 miles, $60 within these zip codes. Okay. You can see flagged rights here. That was written 19 records for each week. I think this was aggregated by or fare amount in this zip code. And see, for 0.2 miles, the fare amount was $52. 0.3 miles, 0.1 mile, which is like you're just sitting in the cab and he charged $52. It hasn't moved. It just stayed there for an hour or so. So it charged $52. So these are the flagged rights. unusual, for these distances in this sphere. Taxi raw records, we know it'll be same like that sample, right? Same like trips data only. We just read the data and wrote it here. Cool.
Yep.
Okay. Anything else? I want you guys to practice these two. These are comparatively simpler for you guys to get started on DLT. There is one SQL, there's one PySpark. I will publish this probably not right now, by end of day today. You guys can practice this. Okay. Setup is more important one time. This is where I think you will get some issues. Not this. Setting up this. How many of you guys have set up actually this paid subscription and Databricks, or how many of you not done yet?
I haven't done it.
Okay.
I
I
didn't
have
do
not
that,
done it.
Harun. It means just I have Databricks, but I didn't do sign on to Azure.
You mean you have the community edition?
Yes, I have the community edition.
Yeah.
That's good enough, or we need to sign for this one too?
Yeah, you have to, because community edition does not have support all of the use cases. It's only for the foundation, like basic stuff, bad jobs only. You know, Catalog and bad jobs, streaming within the sample data and all of that. But if you have to do these use cases, you have to have the paid version of the Azure Databricks.
And if anybody is still in the university, if you log in with your university mail, they give you $200 credit for 1 year. But you'll have to use it's not working for the US East and US West servers. Harun,
And
you'll
use
have to
Central
use
US,
UK
right?
South. I tried, but it said quota exceeded or something like that. So I switched to UK South and it was working.
Oh, okay. I don't know. So, I mean, as I said, right, I had the quota exceeded issue, but I was showing you the other thing. How we fixed it, like here, quotas can go and request new quota where you can increase your machine, limits here. So now,
Yes, sir. But I was talking about that basic 4GB 14. Even for that, it was if you're using a student edition. Like I'm just
okay,
asking
fine.
if somebody don't want to
Whatever
spend.
works for you is fine,
Yeah.
but let's make sure you have this. So if you want to practice Azure Event Hub streaming, or you want to practice DLT, this is needed.
Want to sign to Azure Databricks or just Azure?
No, once you have Azure subscription
Okay.
account, then
Mhm.
these are all services. And see, if you create a subscription, then you create resource group, then you create Azure Databricks service.
Okay.
Okay. And event hubs. You don't need this AAC Unity catalog. This you don't need. But basically, you need a subscription, resource group, Databricks service, event hubs. Last time in one of the videos when we did event hubs, I have shown you how to create these resource group, and you see workspace is anyway you will create from here Azure Databricks. If you click, you get the subscription Databricks service. You can just name anything workspace, but you need to have the resource group, subscription, resource group, workspace, and the event hubs namespace. This is for the streaming example, event hubs. For DLT, you need the subscription, resource group, Databricks service. Once you have this, then you can create those in the Databricks, Azure Databricks. Once you create this and go, you'll get this, launch your workspace. So you have to need this, you need a resource group, manage resource group. It will automatically come. Pricing tier, you to take premium. And this is a subscription. This is the resource group. Location is Central US. So once you have this and create the workspace, then you can launch and then work on that. Okay. Get started with that. Practice these two. And this will be, I will ping you this as well. This will be your assignment. You can take a week or two. Once you practice the other simple ones, you can get started with this. We can discuss, but basically, it's again getting the weather data from online, from this URL, and then creating the weather history data. So these are the data quality checks, right? Slowly changing dimensions, create streaming live table, apply changes, type 1, type 2, how it updates the tables. This is again selecting the JSON fields from the JSON. Okay. Don't get too overwhelmed. It looks like that, but yeah, once you get a hang of it, it shouldn't be difficult. I will post this, and then if based on the time, we can also discuss this. Okay. All right. So I will be wrapping up this session early, as I said, early today. We have some event that we need to attend. What is the other thing that we have here?
In yesterday's class, you told that copy from the Git, right? So that is valid only 60 hours. Still,
Yeah,
can
that is.
we register? Still, can we register and do it, or is
No,
it
no,
over?
that is done. That is done.
Oh,
Over.
okay.
Even I lost that. I got a mail that that ended, access ended. So they will publish again whenever there is an event. You can register to that event. Hands-on, they will publish like last time, right? So watch out for that. Once you get that event, register it, attend it, so that they will send you all the links, and then that will be valid for 3 days. You can use that lab.
Okay.
All right.
Yeah.
Okay. All right, guys. That is all I have today. As I said, we are wrapping up a bit early today. But keep practicing. I will upload the recording and the notebook, DLT notebook information. For the New York taxi, it's already there. I have shown you. You can clone it. Everything is there. For the baby names, I will upload the notebook so you can run and practice that. Okay. All right. Any other questions before we wrap up for this week? Are you feeling all good?
Yeah.
Yes, sir.
Yes, sir.
Okay, great.
Yeah. Yeah.
Yes.
So let me know if you have any feedback, if you are having any issues, concerns about your learning, you are feeling any difficulty or confused or questions, let me know. Ping me. Okay.
Sure. Thank you.
All right. Great, guys. Thank you. Take care. Have a good rest of the day, rest of the weekend. Practice. And I will also ping the other use cases assignment in the group. we can work on that. As Srini said, in a couple of weeks, you guys can work on that and give a demo. And we also want you guys to talk about the certification, those topics. We are following that curriculum Srini has published, and I will review it. We are almost there. I think we have 2 or 3 more modules to be done, and then we'll wrap up with the certifications. Okay.
Yeah.
All right. Thank you.
Okay, Arun.
Take care.
Thank you.
Have a good day. Bye.
Yeah, thank you.